Ever pondered why the night sky is dark even though it's filled with countless stars? This is the question that baffles scientists, and it's called Olbers Paradox. Welcome to the fascinating realm of cosmic mysteries, where we delve into the enigmas that have intrigued the greatest minds for centuries. Today we'll explore a paradox that seems simple at first glance but is truly a conundrum of cosmic proportions. Imagine, if you will, a universe filled with billions upon billions of stars. Each one, a blazing sun, casting its light across the vast empty reaches of space. Yet when we look up into the night sky, we see not a bright canvas of light but rather a dark tapestry sprinkled with pinpricks of starlight. This observation is not new, it's something that has puzzled stargazers for ages. It's a question that has echoed through the ages, from the ancient philosophers to the modern astrophysicists. Why is the night sky dark? This is the crux of Olbers Paradox. Named after the German astronomer Heinrich Olbers, who popularized it in the early 19th century, this paradox presents a seemingly simple question that has profound implications for our understanding of the universe. If the universe is infinite and filled with stars, shouldn't the light from all those stars make the night sky as bright as day? Why then do we see darkness? What's blocking or absorbing all that starlight? It's a question that's as perplexing as it is intriguing. This paradox challenges our basic understanding of the universe, questioning our perceptions and pushing the boundaries of our knowledge. It's a cosmic puzzle, a riddle wrapped in a mystery inside an enigma. This paradox, named after Heinrich Olbers, is a cosmic conundrum that we will delve into today. Prepare to embark on a journey through the cosmos, as we try to unravel this enigmatic paradox and shine a light on the darkness of the night sky. The universe is full of mysteries, and Olbers Paradox is one of the most captivating of them all. So, what exactly is Olbers Paradox? To put it simply, it's a contradiction between the expectation that the night sky should be bright, and the reality that it's dark. In other words, if we live in a universe that's infinitely large and filled with stars, shouldn't our night sky be ablaze with light? After all, no matter where we look, our line of sight should eventually land on a star, right? But instead, when we gaze up into the night, we're greeted by a dark, serene, and star-speckled sky. This intriguing contrast is what we call Olbers Paradox, named after the German astronomer Heinrich Wilhelm Olbers, who popularized it in the 19th century. So let's break it down a bit further. Picture this: you're standing in a forest. Wherever you look, your line of sight ends on a tree, right? Now imagine the forest is our universe and the trees are stars. If the universe is infinite, that means there are an infinite number of trees or stars. Hence, no matter where we look, our line of sight should end on a star. Let's delve deeper. Imagine you're looking at a wall covered in countless tiny pictures. Now the closer a picture is to you, the larger it appears and the more it catches your eye. The pictures further away appear smaller, but if you look closely, you'll still see them. Now apply this concept to stars. The closer stars are brighter and more noticeable, while the ones far away appear dimmer. But if there are indeed an infinite number of stars, even the faint light from the distant ones should add up, making the night sky a canvas of unending light. However, when we look up at the night sky, it's not a blinding light show. Instead, it's a tranquil black canvas, punctuated by the twinkling of distant stars. This is the paradox. If there are countless stars in our infinite universe, why isn't the night sky as bright as the surface of the sun? One might argue that perhaps there's dust in space that blocks out the light from these stars. But over time, the dust itself would heat up and start glowing as bright as the stars. So that can't be the solution to our paradox. Another argument could be that stars obstruct each other, but given the vastness of space and the relative size of stars, this is highly unlikely. For instance, despite the millions of trees in a forest, you can still see the sky through gaps in the canopy. Similarly, in space, stars are so far apart that they wouldn't block each other out. Yet another thought might be that not all stars are bright enough to be seen from Earth. However, remember that the paradox assumes an infinite universe, meaning an infinite number of stars. So even if only a small fraction of these stars are visible, their combined light should still illuminate the night sky. So, we're left with this conundrum. The very fact that our night sky is dark rather than blazing with the light of an infinite number of stars contradicts what we would expect in an infinite, star-filled universe. This seemingly straightforward observation leads to a complex question: why is the night sky dark? Many theories attempt to resolve this paradox, each with its own strengths and weaknesses. Let's start with the finite universe theory. This theory proposes that the universe is not infinite, but has a definite size. If the universe is finite, then there are only a finite number of stars. Therefore, the night sky isn't infinitely bright, answering our paradox. However, this theory is not without its drawbacks. If the universe is finite, what lies beyond its boundaries? This question plunges us into deeper mysteries, and this theory fails to provide an answer. Additionally, our current understanding of astrophysics suggests the universe is indeed infinite, making this theory less probable. Next up is the theory that the universe has not existed forever, but has a specific age. This is known as the non-eternal universe theory. If the universe had a beginning, then light from distant stars might not have reached us yet. This could explain why every line of sight does not end on a star, and therefore why the night sky is dark. This theory has a considerable strength. It is consistent with the widely accepted Big Bang theory, which states that the universe began from a singularity approximately 13.8 billion years ago. However, it's not foolproof. The universe is vast and light from many stars has had ample time to reach us. So, while this theory helps, it doesn't fully resolve Olbers' paradox. The third theory we'll examine is the expanding universe theory. This theory suggests that the universe is not static, but is expanding. As a result, the light from distant stars is redshifted, meaning it moves towards the longer wavelength, lower energy end of the spectrum. This redshifted light is less likely to reach our eyes, which could explain the darkness of the night sky. This theory aligns with the currently accepted cosmological model, which posits that the universe has been expanding since the Big Bang. It also explains the observed redshift in light from distant galaxies. However, it doesn't entirely solve the paradox either. Even redshifted light should brighten the sky if the universe is infinite and filled with stars. Let's not forget the dust theory. This proposes that interstellar dust absorbs much of the starlight, preventing it from reaching us and thus darkening the night sky. Sounds plausible, right? But here's the catch. The absorbed light would heat the dust, which would then re-emit the light, eventually filling the sky with light and bringing us back to square one. Finally, we have the aged star theory. This one suggests that not all stars have been shining forever. Stars have life cycles, after all. Some burn out and become white dwarfs, neutron stars, or black holes. These objects emit far less light than their progenitor stars, which might help explain the dark night sky. The strength of this theory lies in its accordance with our understanding of stellar evolution. But again, it doesn't entirely resolve the paradox. Even dead stars should eventually fill the sky with light if the universe is infinite and eternally old. So, where does this leave us? Each of these theories brings us a step closer to unraveling Olbers' paradox. They provide valuable insights into the nature of our universe and stimulate further questioning and research. Yet, each theory also falls short in some way. None of them can fully explain why the night sky is not ablaze with the light of an infinite number of stars. In the end, it's likely that no single theory can completely resolve Olbers' paradox. Instead, the answer probably lies in a combination of these theories. The universe might be finite in some respects, and infinite in others. It might be expanding, filled with dust, and populated by stars of varying ages. It's a cosmic jigsaw puzzle we're only beginning to piece together. Each theory offers a unique perspective, yet none provide a definitive answer. One of the most accepted theories is that the universe is expanding. But how does this solve Olbers' paradox? Well, let's dive right into it. The expanding universe theory is a cosmological model that suggests the universe is not static, but is instead growing larger with time. You can think of it like a balloon being inflated. As you blow air into it, the balloon expands and the dots on its surface move farther apart. This is a simplified way to visualize how the universe is expanding. Edwin Hubble, an American astronomer, first proposed this theory back in the 1920s. He observed that galaxies seemed to be moving away from us in all directions. This movement is known as redshift, and it's caused by the stretching of light as it travels through the expanding universe. Now you may ask, how does this solve Olbers' paradox? The paradox, as you'll recall, is the question of why the night sky is dark when it should be filled with the light of countless stars. If the universe were infinite, static, and filled with an infinite number of stars, the sky would indeed be ablaze with light. But if the universe is expanding, this changes the game entirely. In an expanding universe, not all light from all stars has reached us. This is because the universe has a finite age. It's estimated to be around 13.8 billion years old. That's a long time, sure, but in cosmic terms, it's not infinite. This means that there's a limit to the distance that light could have traveled since the universe began. This limit is known as the cosmic light horizon. Anything beyond this horizon is simply too far away for its light to have reached us yet. And since light takes time to travel, the farther away a star is, the more time it takes for its light to reach us. In addition, the universe's expansion means that some stars are moving away from us faster than the speed of their light. So the light from these stars may never reach us at all. This is a mind-boggling idea, but it's one that cosmologists have embraced. Furthermore, the universe isn't just expanding, but it's expanding at an accelerating rate. This means that the universe is getting bigger faster as time goes on. Consequently, more and more stars are moving beyond our cosmic light horizon, and their light will never reach us. So, in an expanding universe, there are many reasons why we don't see the light of all stars. Some stars are too far away for their light to have reached us yet. Some are moving away from us so fast that their light will never reach us. And some stars' light is stretched into longer wavelengths, or redshifted, to the point where it's no longer visible to the naked eye. These factors all contribute to the darkness of the night sky. They help explain why we don't see a sky filled with the light of countless stars. Instead, we see a dark sky speckled with the light of only the relatively nearby stars whose light has had time to reach us. This is the essence of the expanding universe theory and how it addresses Olbers' paradox. It's a grand and beautiful theory that marries the vastness of the universe with the finite speed of light. It reminds us that while the universe may be unimaginably huge, we are only able to perceive a small part of it. And it's this limitation that helps explain why the night sky is dark. So the universe's expansion could be the key to unraveling this cosmic mystery. The truth is, there is no one-size-fits-all answer to Olbers' paradox. This cosmic enigma, like a Rubik's Cube of the universe, continues to baffle astronomers and scientists alike. Despite the countless hours spent peering through telescopes, crunching numbers and theorizing, the paradox remains one of the biggest unsolved mysteries in astronomy. The beauty of science, though, lies in the journey and not just the destination. The quest to solve Olbers' paradox has led us down a path of discovery and innovation. It has sparked conversations, fueled debates, and challenged our understanding of the universe. It has pushed us to question, to explore, and to dream. Ongoing research and exploration in this field are like pieces of a grand cosmic puzzle. Each piece, each discovery, each scientific breakthrough brings us a step closer to understanding the paradox. From the Big Bang theory to the expanding universe theory, each hypothesis adds a new dimension to our understanding of Olbers' paradox. Yet the paradox continues to elude us. It's like trying to catch a shadow, always just out of reach. But this doesn't mean we stop. On the contrary, it motivates us to dig deeper, to look further, and to never stop questioning. After all, the greatest scientific discoveries often come from the biggest mysteries. So while we may not have a definitive answer to Olbers' paradox yet, we have gained valuable insights into the universe and our place within it. We've learned that the universe is not static but dynamic, always evolving and changing. We've discovered that light doesn't just travel in a straight line, but can be bent, warped, and even absorbed by the universe's various elements. In essence, Olbers' paradox has opened our eyes to the vastness of the universe and the infinite mysteries it holds. It's a reminder that there is always more to learn, more to discover, and more to explore. In the end, Olbers' paradox reminds us of the infinite mysteries the universe holds, waiting for us to uncover. So, there we have it, a journey into the depths of the cosmos and the mystery of Olbers' paradox. We began our journey with the cosmic enigma, the paradox that has intrigued astronomers for centuries. Why is the night sky dark when it should logically be flooded with light from the infinite number of stars in the universe? This strange phenomena is known as Olbers' paradox, named after the German astronomer Heinrich Olbers, who popularized it in the 19th century. We then delved into the paradox itself, dissecting it layer by layer. It's a simple question with complex answers. If the universe is infinite and uniformly filled with stars, why isn't the night sky as bright as the surface of the sun? The paradox is a contradiction between the assumption of an infinite static universe and the observed darkness of the night sky. We ventured into the realm of theories and counter-arguments, where we found an array of explanations. Some suggested the universe isn't old enough for the light from distant stars to reach us. Others proposed that the universe isn't static but expanding, causing the light from distant stars to redshift into the invisible spectrum. The expanding universe theory emerged as a strong contender in explaining the paradox. The universe, according to this theory, is not static but dynamic and ever-expanding. This expansion causes the light from distant stars to redshift into the invisible spectrum, explaining why the night sky is dark. Finally, we arrived at the verdict. The paradox remains a mystery, a cosmic enigma. The expanding universe theory offers a compelling explanation, but the paradox still fuels ongoing research. The mystery of the dark night sky continues to captivate scientists and stargazers alike, inspiring a relentless quest for answers. As we stare into the night sky, we are reminded of the paradox and the countless mysteries that the universe holds. Until next time, keep on questioning, keep on exploring.